I'm going to talk about the context of what we do. We're really concerned to a large degree about nuclear weapons materials, and the proliferation issues that we worry about relate to a large degree to the non-weapons uses of nuclear materials, specifically plutonium and highly enriched uranium. And so there's on the one hand, we try to verify what's going on to make sure that the material isn't diverted to weapons use. On the other hand, there's another parallel effort going on to reduce the number of uses of non-weapons uses of fissile materials, so we have less to worry about. And so I'm going to talk about the effort to reduce the amount of plutonium in the world, places it can be found, and similarly the amounts of highly enriched uranium. The weakness of the Non-Proliferation Treaty, and it seemed at the time to be an essential weakness, or a major weakness, is this use of nuclear weapons usable materials for other purposes. What we found as time has gone on is that many of these uses, and perhaps all of them, are not necessary and can be substituted with other materials, low-enriched uranium in particular. And in that case, our verification challenge is much reduced, and I'd just like to give you an overview of where we stand. The vulnerability of the non-proliferation regime to this challenge is not just a theoretical one. In South Korea, especially after North Korean nuclear tests, a majority of the public, when polled, says that South Korea should have nuclear weapons as a deterrent against North Korea. But the way in which that manifests itself in the near term is that there's pressure on the U.S. to agree that South Korea should be able to separate plutonium in the same way as Japan does. In the case of highly enriched uranium, non-weapons use of highly enriched uranium, it came up in connection with our negotiations with Iran at sort of the peak of the crisis before this current administration in Iran was elected, where the head of the Iranian Atomic Energy Organization said Iran was expecting to need nuclear submarines in the future, and therefore there was a reason to start thinking about producing highly enriched uranium, which would have, of course, driven us crazy, completely crazy. Now, with regard to the situation of, we talk about plutonium and highly separated plutonium and highly enriched uranium. This is the global situation where we have, on the one hand, a legacy of the Cold War, the weapons materials that were produced, and then on top of this, a growing stockpile of civilian plutonium that was originally the separation of this plutonium was launched in the expectation that by now we would have thousands of plutonium breeder reactors, and we needed the plutonium to start them up. Well, it's accumulating. We don't have, we only have 2 prototype breeder reactors which aren't quite working yet, one in India and one in Russia. So that's a problem. But there's also the whole justification of this plutonium separation program is getting weaker and weaker, and there's a hope that that finally this whole area of activity may be closed down. In France and Japan would like to imitate France, the continuing separation of plutonium is justified by recycling it, but into so-called MOX, mixed oxide plutonium and uranium fuel for the reactors from which it came. But the cost of that fuel is 10 times the cost of the low-enriched uranium fuel that would otherwise be used. And so the utilities don't want this program, and you know, there's a hope that the invisible hand of the market will finally shut down this activity, as it is doing in the UK. Now, with turning to highly enriched uranium, here the production has been for military purposes, and then primarily, and then there have been some civilian use for research reactors, and also non-weapons use in naval reactors. And you can see that basically we don't have ongoing production except on a scale that's invisible on this graph. The amount of the number of weapons in the world have gone down a lot more than the amount of highly enriched uranium. This has created a large stock of excess highly enriched uranium, some of which was blended down to low enriched uranium for power reactors, and some which is unallocated. The uses of, there's about 1,000 tons of excess highly enriched uranium in that previous graph. We're using about 7 tons a year, so that it's a long time before we would have to produce more. And in fact, we've been phasing out most of these uses of highly enriched uranium. Research reactors, we're converting to low enriched uranium targets for medical isotope production and so on. The big remaining use is naval reactors. Here, by the way, I just show that the U.S. and Russia, have most of that excess highly enriched uranium, and that the U.S. has actually designated a stock of its excess weapons-grade uranium for fueling our naval reactors, and the projection is that that's enough for 50 years or so. Russia has much more. So the discussion of the naval use of HEU has started in our country. And it's for both aircraft carriers and for submarines. There are 6 countries with naval reactors, with nuclear-powered ships. U.S. and UK pair them because we share technology with the UK, and actually we supply the UK HEU. And then Russia and India use actually not fully weapons-grade uranium mostly, and there's some pairing because Russia has shared technology with India. And then there are 2 other countries which use low-enriched uranium. And the question is whether, which is now being discussed, is whether the U.S. can shift to low-enriched uranium. The U.S. is the biggest user the U.S. Navy is the biggest user of HEU globally. In 2013, the Office of Naval Reactors and DOE said maybe it's possible, and then Congress asked for an R&D plan, and the current position of the Office of Naval Reactors is that, in fact, it would like to develop, if given $1 billion, would like to develop a low-enriched uranium fuel for aircraft carriers, but it's not so sure about submarines. And the argument is that, of course, there's a lower density of energy in low-enriched uranium than highly enriched uranium, would require, and the U.S. Would not like to refuel its reactors more frequently. You need larger reactors, larger cores. They could fit in the aircraft carriers, but not into the submarines as currently designed. So the connection with verification is that, of course, if we don't have plutonium separation anymore, we won't have this nagging problem that we've had of the uncertainties, the 1% or so uncertainties between what goes into a reprocessing plant and what goes out, and whether some plutonium is coming out someplace else. The 1% uncertainty is significant for a reprocessing plant like Japan's, which is designed to, if operated at design capacity, to separate out 8 tons of plutonium a year, which is about 1,000 weapons equivalents. In the case of the verification, in the case of the highly enriched uranium, this has been a real problem in the Nonproliferation Treaty and would be in the Fissile Material Cutoff Treaty as well, because you would have a verification system trying to verify the non-diversion of highly enriched uranium from a military fuel cycle, and you would run into real sensitivities there. And so if, in fact, we switched to low-enriched uranium in that fuel cycle, that problem would be ameliorated. Of course, if we reduce, to the extent that we reduce the use of nuclear weapons materials for non-weapons purposes, we would stabilize the non-proliferation regime and also reduce the chances of diversion to nuclear terrorism. So in summary, plutonium separation and use are not economic. They're really, these programs are just proceeding by inertia where they are proceeding. In the case of highly enriched uranium, there's no need to produce more for at least 50 years because the legacy of the excess from the Cold War. Within the next decades, almost all HE fuel reactors, other than naval reactors, could be LEU fueled or retired, and now we have this the discussion of whether, in fact, we could convert to naval reactors to LEU as well. I didn't mention it, but transitioning Russian and Indian naval reactors to LEU would be much easier than for the U.S. and UK, because they refuel regularly. The U.S. has been moving to lifetime cores, and also the enrichment of their cores is not as high. So the result of this movement away from use of weapons, usable materials for non-weapons purposes would be a more verifiable and stable non-proliferation and nuclear reduction regime. Thanks.
But here, instead of using reflective spheres, solid spheres, I use Francesco De Rico famous bubble detectors at Yale to do the same feats.